All right, hello class. This is Dr. Cooper. This lecture is covering chapter 15 in Wade's ninth edition of organic chemistry. We're currently covering material with conjugated systems. Okay, this is an overview for chapter 15 lecture. All right, first we'll discuss conjugation or conjugated systems. We'll talk about the newfound stability of conjugated organic materials. This new reaction chemistry to discuss this conjugate addition, also known as the 1,4 addition. Reaction selectivity comes up. If I have a conjugate carbonyl, do I get the 1,2 or the 1,4 addition product? We'll talk about how to govern that selectivity. There's two ways with reagents. So there's key organic metallic reagent, or Grignard's versus the organolithium versus cuprates will have different selectivity. And also we can change the reaction conditions from kinetic or thermodynamic conditions, and that will also govern either the 1,2 or 1,4 addition products. All right, we'll discuss nomenclature of dienes and trienes. All right, we'll talk about this new chemistry, new reaction chemistry of dienes, the very important Diels-Alder reaction. The Diels-Alder reaction is a pericyclic reaction. It's known for preparing 6-member rings. It's also classically referred to as the 4+2 cyclic addition. With Diels-Alder reactions, I have to study which reagent is a diene versus the dienophile. If I'm using cyclic dienophiles, I get fused rings. If I'm using cyclic dienes, I get a bicyclic product. Stereochemistry is important. We'll talk about this Endo rule. And with unsymmetrical dienes, there's two major products that are potentially possible. The 1,2 versus the 1,4 product again. We'll talk about which diene affords which major product, either the 1,2 or the 1,4. UV-vis spectroscopy is briefly discussed. And lastly, if I have a planar cyclic array of an odd number of pi bonds, I get a new class of stability that we refer to as aromaticity, and that will lead us into chapter 16. Okay, so what is conjugation? It's organic molecules with alternating pi bonds. Alternating pi bonds can be described as double bonds, single double bonds, or triple bonds, single triple bonds, or a triple bond, single double bond. All right, what's key is that there's a single bond in between either a double bond or a triple bond. All right, that's what we're describing as alternating, is that there's double, single, double, or really just pi, sigma, pi type of scenarios. All right, so which molecule below is conjugated? There's 4 molecules here, molecule A through D. Can you tell me which molecule is conjugated? I'll give you a few seconds. All right, hopefully that was enough time. Let's take a look at molecule A. I see a double bond, a single, double bond, a single, double bond, and a single, right? Those are alternating single, double, single. So this compound is conjugated, right? If I take a look at molecule B, I see a double bond, a single, a double bond, a single, a double bond, a single, a double bond, single, double bond, single. All right. And if you go through this whole molecule again, I would see that same scenario. Double bond, single, right? So molecule B looks to be conjugated. What about molecule C? I see a triple bond. I'll use 3 lines to describe that. And there's a pi bond and a triple bond. There's a single bond, and a double bond, right? So there's an issue here, right? This is pi in the triple bond and a single pi, right? The triple bond has 2 pi's, but it's okay. We're just going to describe one of them. But these 2 pi bonds are separated by 2 what? Single bonds, all right? So that's not alternating. And if I look at molecule D, there's another pi bond in this double bond to oxygen, right? I can go single, but there's still another single before I get where? To this double bond, right? So these 2 systems here at the end are not conjugated. The pi bonds are instead are isolated. So that's the term that we like to use when they're not conjugated, is that they are instead, okay, isolated. So the pi bonds of molecule C and molecule D are not conjugated. Instead, they're isolated. So what's the answer to which molecule below is conjugated? A and B are conjugated organic molecules.